Microphone testing. Thank you. Thank you very much. This is another topic. This is another property of ionic compounds. So we've been studying properties of ionic compound. The first one is already finished. That was electrical conductivity, and this is now melting and boiling points of ionic compound. This part will be divided into two parts. Today we'll discuss a bit, and next day we'll have the next part. So this is the second property. What is that? Melting and boiling points of what? Ionic compound. I start with an example. Sodium chloride is an ionic compound. I think you are clear about this. And another compound, hydrogen chloride, is this ionic compound? No, it's covalent. And how about water? Is this ionic compound? No. This is still covalent. Okay, now we are comparing the melting point of these two compounds. Which one is the ionic there? This means sodium chloride. Okay, so this has a melting point. You probably know, everybody. What is that? 0 degree centigrade. If you have some ice and bring the ice from the refrigerator, this will melt at 0 degree. Is this high or low? Right? Is this 0? Right? Is this high or low? It's very low. Low melting point. Okay. But do you know the melting point of sodium chloride? Yes, it's 800 plus degrees centigrade. So isn't this very high or low? Yes, this. If you compare this to this has very low melting point and this has a very high melting point. Its boiling point even higher, as 1400 or 1600 something. Very high melting point. So when you get this, do you have question that why so high? Do you have this question in your mind? If you don't have, you should leave internet, mobile, because you should be mentally healthy to have the question. Okay? So I say the healthy questions should appear in your mind logically. I say this melting point is so high. How come? Why? It should be a question. And whenever we get students with question, they learn quickly. Okay, students with question learn, the smart learner. So why is the ionic compound melts at very high temperature? That's the thing we're going to learn. Okay, and what does it mean that melting of sodium chloride? First, I show that. First, I'm going to show what do I mean with melting of sodium chloride. You know, sodium chloride means you see this formula, but this formula doesn't represent sodium chloride correctly, right? It actually consists of ions, and then it actually consists of many ions. Okay, many ions. I repeat this information many times, and next days in the next classes I will also be repeating this. Okay, but some are okay. So here I write more of this. See here, this is single layer. I can write more of the ions, but no more. You understand, because we started, this is called ionic lattice, right? Ionic lattice. And when you look at this structure, do you think this is solid or liquid? What do you think? If you look at this, solid or liquid? Solid. Now how to understand? How to understand this is solid, not liquid? Yes, because they're closely packed and they're regular layers. Two things there, two informations there. If you use your common sense and look at this, you understand this is solid, right? And now I write, here is in a container, suppose, and here is another container. I write here sodium chloride, sodium chloride, sodium chloride, chloride. And look at this. Is this solid or liquid? Yes, very good. Because the distance, little distant, distance between two ions greater and little irregular. Little irregular. Okay, this is solid and this is liquid. Okay, solid and liquid. Okay, and if you want to turn the solid into liquid, you should make them this. like this. Okay? And how to make this structure like this? Which things are going to do? What to do there to make the solid order, the arrangement like this? Just to heat, it's a heat. Okay. What the heat will do? The heat will, here, look at this. The particles are closer here, right? And also regularly arranged, right? And when you melt them and turn into liquid, look at the arrangement. They are a little distant. When a cation attracts an anion, cation attracts an anion, they're close together. This is why they're solid. And the attraction is strong. We said it's strong electrostatic attraction. What do you say? Strong and electrostatic. Electrostatic attraction is a type. And what the strong mean? Extent of the attraction. Okay? They're close, they're strongly held together, right? And how about this? Are the ions strongly held together? No, they're a little distant. So when you make a solid liquid, then you are separating the ions, right? For a while, you are separating the ions, right? Right? And when two ions attracts each other strongly, and if you want to separate them, so what things you need to do? Force, right? Force. You need to force. If the attraction is strong, then you need strong force. Yeah, strong force. The force is coming from kinetic energy. And force is by heating. Everybody clear? Force is by heating. We heat, the heat will separate them. Everybody clear? So guess how much energy should require to separate them like this, to weaken the attraction. Excuse me, as this is liquid, the attraction is still there. Between opposite ions, there must be attraction because this is still liquid. If there were no attraction, then this could have been gas, right? In gas, particles are not attracted to each other. If there is any attraction, they will fall into liquid. If the attraction is greater, then that will form solid. This is here, and this is liquid. So here is strong electrostatic attraction. Here is weak electrostatic attraction. Understand? Here is strong electrostatic attraction. Here is, you see, clearly see. Do you see? Yes. Okay. So here you see the distant, little distance, and particles are mobile. So there's less electrostatic attraction. And to make this, to have this happen, you need to heat. It means they will separate the ions by overcoming the attraction. By overcoming the attraction, what do you call the attraction? Repeat. Strong electrostatic attraction. Okay? Strong. Which means you need to weaken. I say weaken. Why weaken? Why not break? Why don't I say to break the electrostatic attraction? Yes, very good. Because we're turning into liquid. In liquid, they also have, they still have electrostatic attraction. They still have electrostatic attraction. So you have weakened the electrostatic attraction, right? Not the breaking of electrostatic attraction. If you break the electrostatic attraction, that will turn into gas. Are you clear, everybody? Simple. So how to do that? That's by heating. And this needs very high temperature, large amount of heat. Why? Why this needs very large amount of heat? So yeah, this is there. You are weakening the attraction, which is very strong. You are going to weaken the attraction, which is very strong. This is one reason. Okay, are you able to write this for any ionic compound? Why is the melting point of ionic compound so high? Can you write this? Where's that? The electrostatic attraction between cations and anions? Very strong. Clear? Are you able? Okay, because this is normal sense. Because the ions, oh, don't say intermolecular forces. Never say intermolecular forces. Because they're ions, not molecules. Okay? And molecules means group of atoms. So are there any atoms? Here are ions. So you shouldn't say intermolecular attraction. There is no intermolecular attraction. What do you call that instead? Electrostatic attraction. Understand, everybody? So electrostatic attraction between cations and anions is very strong. Okay, very strong. So, let me know another reason. Another reason that's why it needs large amount of heat. Another reason, other than you say attraction between a cation and anion is very strong. There should be another reason. What is that? Yes, regular arrangement. I show you. Okay, I show. Everybody look at this. If we have a brick, everybody look at this. If you have a brick, okay. Is this okay? No, not yet. Is it okay now? Okay. What do you see there? Brick. Very interesting. You see that brick. Okay, this is a brick. Think that this is a brick, right? Okay. And here is another brick. And you know how to join two bricks? By cement. Yes, cement is kind of bonding. Cement means bonding. So use a cement. And now, if I join them with the cement here, and if we want to separate them again, separate them, breaking the bond or cement, you want to separate them. How much energy do you think you will require? Large amount of energy or small amount of energy? And it depends on which cement is there, right? Doesn't depend on which cement. If the cement is damp or weak cement, do you need large amount of energy? No. If the cement is strong, then energy required to separate them is strong, right? So what was there in sodium chloride? Is the attraction between a cation and anion strong or weak? Are you sure? Because they are oppositely charged and strong electrostatic attraction, right? So if here the cement between these two are good cement, this is very good cement, then this will need large amount of effort, okay, or energy to separate them. Clear? Clear? So this is the reason you get the cement is strong, so I need large amount of energy, okay, to separate them. Now get, and if I give you another option, should the energy required more or less? Here is one, another brick. Here I gave some other bricks. Here is another bricks. And here are some more bricks too. Suppose there are many and many bricks too. So if this happens throughout, do you think this will need less or more energy? Extremely more, yes. Why? Because one, earlier I showed you, one is bonded with another one, right? Now you see, one is bonded with few others. Okay, one is bonded with few others. So isn't the attraction multiple? So don't you think you need multiple amount of energy? Multiple of just separating between two, right? Right. So when you get this now, again, come back and see our sodium chloride. This was our sodium chloride lattice. So here you know the attraction between any two ions is strong, right? Yes. Attraction between any two ions is here strong, right? Is the attraction just between two ions? No. Is here the attraction just between two ions? No. Attraction is here manifold, multiple attraction. One is attracted by few others, right? Sodium is attracted by 6 chloride and vice versa. 6 times. So this will be 6 times more than just attraction between a cation and anion. Are you clear? So energy required will be what? Greater. Are you clear? Energy required will be greater. So now explain why the melting point of sodium chloride or ionic compound is very high. What is that? Because the electrostatic attraction between a cation and an anion is very strong. Okay, complete the sentence. And what's the other point to score mark? Yes. The sense is here multiple. You should write something that gives a multiple attraction. If you don't write this, you will lose a mark. This you say first sentence, attraction between a cation and an anion. This given just between two ions. But if you say the lattice regularly arranged or something like this, if you need to write something like this, which shows that one is attracted by few others. Everyone is attracted by few others. There's a multiple force. Okay. So then the third point you will write. So large amount of heat is required to break to separate the ions or to weaken the attraction. It's for melting. Don't say to break the bonds. You will say what? So now repeat the 3 points. Repeat the 3 points I have mentioned. What is the first one? Anybody else? Not you. You, Nuzaiba. Why the ionic compound smells with very high temperature? So large amount of heat required to separate the ions. Okay, so you should say the first one first. Which one is the strong electrostatic attraction between cation and anion? Then we go for multiple attraction. First you mean attraction, then you talk about multiple attraction. Clear? So that needs very high. You already got that. This needs more than 800 degrees centigrade to melt the compound. Okay. Another thing need to be added here. These are all sodium chloride. Look at their charges. Attraction is due to their charges, right? But if you get another ionic compound with charges like this is permanent marker. Another compound like this, Ca2 plus and O2 minus. If this is also lattice, I just write 2, but this is always lattice. So if you get the ionic compounds like this charge, so should there be less, more, or similar melting point? What do you think? Attraction is there because of charge. So where you get greater charge, here or here? Where is the greater charge? Here is greater charge. Here is 2 plus and 2 minus. Here is 1 plus and 1 minus. Certainly here is greater charge. So if here are greater charge, so here should be stronger attraction between this ion and this ion. Do you think this? Why is the attraction? Again, I have repeat. I cannot. Why is the attraction? Because of charge. What are the charges here? Plus 1, minus 1. What are the charges here? Plus 2, minus 2. So which two there is stronger electrostatic attraction? Between these two or between these two? Here should be stronger attraction between, and you are going to weaken the attraction. So which of them needs greater amount of energy to weaken the attraction? This compound or this compound? Yes. So remember, ionic compounds, all the ionic compounds really have stronger or higher melting point, boiling point. So we can explain 3 points. And if you get 2 ionic compounds, this type and this type, the type with greater charge on the ions will have even higher melting point. Are you clear? Okay. Now we see the last part. Actually, problem is you don't have a habit to think deeply. You don't have a habit, and we don't see students using common sense. We put our common sense in Almira or mobile phone and we then come to the class without common sense. So this is why we cannot think. Many of this is a common problem we get here. Look, I show you now most ionic compounds melt and boil at high temperature. Why? Because ionic compound consists of large number of ions in their giant crystalline lattice. So this gives the sense of multiple, right? Multiple ions. Multiple ions means multiple attraction. You are listening. I don't know whether you're thinking. Because when I ask you, then I understand. So here are multiple ions means multiple attraction. And if there are multiple attraction, look, oppositely charged ions are attracted to each other by strong electrostatic force. The attraction will be strong electrostatic force. So how much energy? A large amount of heat energy will be required to weaken the attraction for separating the ions. Clear? This is why they have high melting point, boiling point. If the ions have greater charge, then melting point and boiling point will be less, right? More, yes. If the ions in the ionic compound have the ions have greater charge, then melting, boiling will be greater, right? For example, calcium oxide have the ions. Calcium oxide compound has the ions with greater charge, right? Which has greater charge? The ions on calcium oxide, greater charge. So the attraction, electrostatic attraction between cation and anion will be stronger, like compared to sodium chloride. So which one has greater melting point? Calcium oxide. So now is there. These are questions. You will see. You will check. Okay. Thank you. No more. Today's topic is finished. Thank you.